Alrighty, welcome to Climate Science and the Anthropocene, Glaciers and Ice Shed Studies. I'm Ellis, and I'll be starting by presenting our contemporary issues concerning glaciers. We've known since the 19th century that humans have been affecting our climate. At this point, the question is not if humans are affecting it, nor is the question about how we're affecting it, but it's definitely about how much we're having an effect on our global climate. Glaciers and ice sheds are a fantastic indicator of the impact that human activities are inflicting on our planet. Many studies have found that humans are affecting Earth's climate primarily by causing increases in the concentrations of greenhouse gases like carbon dioxide and methane in the atmosphere. These gases trap radiation emitted from Earth's surface after it's been heated by the sun, and then the added heat retained in Earth's atmosphere envelope makes its climate warmer. Industrial activities that our modern lifestyles depend on are what's mainly responsible for the massive amounts of greenhouse gases we are observing in our atmosphere. A 2018 study by Sheftel shows that we've raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. We've been observing an increase in the global temperature due to these particles released from human industrial activities, and this increase in temperature is what's causing glaciers to melt. Although there can be a delay of several decades between rising temperatures and their impact on glaciers, we are already observing speedy decreases in the presence of our glaciers. During the maximum point of the last ice age, glaciers covered about 32% of the total land area, but presently glaciers only cover 10% of land area. This decrease in the presence of glaciers causes several issues. When temperatures rise, and ice melts, more water flows into the seas from glaciers and ice caps, and ocean water warms and expands in volume. This combination of effects has played a major role in raising average global sea level between 4 to 8 inches only in the last 100 years, according to the Intergovernmental Panel on Climate Change. The fact that our sea levels have begun to rise have already caused several issues. These issues include things such as sinking land, eroding coasts, overwhelming dike systems, levees, and pump stations. The land and technologies that we have in place are already suffering from the increase of the volume of water in our oceans. Furthermore, when sea levels rise, the salty water covers the land, which can sink into underground aquifers, and when this happens, it jeopardizes the fresh water that we use for drinking and crop production and agriculture. Furthermore, the fact that more than 100 million people worldwide live within only 3 feet of mean sea level in megacities where human populations have concentrated near coastal plains of river deltas. Cities such as Shanghai, Bangkok, Jakarta, Tokyo, and New York are all at risk. This fact poses issues that are both economic, political, and social. So for one, not only will this cause mass amounts of people to migrate, an example of a social issue, it will also put huge trade and information centers at risk. It will cause the loss of international business hubs and the loss of land and resources. In terms of politics, the melting glaciers cause increases in sea levels is quite a complicated issue. The way that we use resources for industry generates money and runs our lifestyles, but the losses we'll experience and that we're already experiencing are just as significant. There is a direct relationship between the increasing amount of particles in our atmosphere, the increasing temperature of our planet, and the decline of glaciers. We are already observing the effects that melting glaciers can have on our planet, and therefore we simply cannot ignore this issue and leave it for future generations. The research of this environmental threat has been growing rapidly for the last couple of centuries, and to fully understand how we know what we know now, we must go back and look where the research began.
My name is Mia Thomas, and I'll be doing the historical context of glacial studies. It is within the next 15 to 20 years that we will be seeing the disappearance of many famous glaciers all around the world, such as these glaciers right here in Glacier National Park. The study of glaciers and their influence on geomorphology has been studied since the early 1800s. Beginning with the scientists Jean de Carpentier and Louis Agassiz, we have theories that help us make sense of why our world looks the way it does and how the cycle of cooling and warming of the planet works. The scientific works of these men became an integral part of the way geology and geomorphology is studied. The continued study of glaciers has allowed scientists to use what is known about glaciers to study the changes in our climate. Without the initial curiosity of scientists a couple of hundred years ago, we would not have the ability to understand and predict ways in which glaciation and climate change are related. While glaciers are recognized and observed by many early civilizations, such as the Romans and Greeks, the first to publish a theory on the study of glaciers was a Swiss-German scientist named Jean de Carpentier. His curiosity was sparked after a glacially dammed lake near Valais, Switzerland, burst through the glacier and sent millions of gallons into the valley below. He went to study the valley below the glacier was full of large granite rocks, or erratics, and that had the exact mineral makeup of the alpine peaks above. He began to theorize that these erratics could have only been moved by ice. He worked closely with another scientist, Louis Agassiz, on developing the glacial theory. They each published works explaining the science of ice ages and were met with critics who thought this theory was ridiculous. Carpentier was able to refute other current hypotheses explaining the presence of erratic blocks. Nevertheless, when he introduced his glacial theory in the paper read before the Schweizer's Nachforschung in Geneva in 1934, he was met with incredulity and scorn. Though he was first met with opposition, the theory was eventually fully accepted in the early 1870s. After the theory became widely accepted, many researchers spent their time trying to understand the functions and characteristics of glaciers, hoping to confirm de Carpentier's and Agassiz's work. One scientist who did notable work was Norwegian researcher Fridtjof Nansen. Nansen and his team were the first people to cross Greenland, therefore identifying that it was indeed covered by an ice sheet, supporting de Carpentier's and Agassiz's theory. Many scientists also spent time researching the Antarctic ice sheet. James Clark Ross was an early Antarctic explorer who explored the continent around 1840. Ross was the first to establish that Antarctica was a continent, not just a series of islands. Ross discovered the Victoria Barrier, a massive ice shelf that was later named after him. By discovering these massive ice sheets and strengthening the claim of previous ice ages, both Nansen and Ross are important contributors to our knowledge of ice ages today. One of the most important studies ever done on glaciation and its relation to climate science is the Vostok ice core, taken from Lake Vostok, a glacial lake in Antarctica. This became an extremely accurate way to observe the past changes in climate. Changes in the atmospheric composition are indicators of a change in climate. The ice core is such an accurate way to depict change. Bubbles are trapped in the ice of the glacier. Because scientists were able to track many years of climate change, glaciers became a very important aspect of climate science, and this technology has allowed for a deeper understanding of the climate cycles our planet endures. The past 2 centuries of scientific discovery in the field of glaciation has allowed for an understanding of the way glaciers have formed and changed our planet, as well as have allowed us to understand the impact that climate change has on the glaciers. We use this information we have learned in order to move on into understanding the future of glaciation.
I'm Ellie Polk, and I will be reframing the issue, the future. As we know, glaciers serve as year-round snow and ice sheds in mountain regions, supplying watersheds with seasonal runoff. In addition, ice sheets and permafrost in the Arctic and Antarctic must remain in place in order for wildlife to thrive, global climate to maintain stable trends, and for water sources in the surrounding areas to be replenished during the regular melt months. As we look at the future of glaciers and polar ice sheets and how global climate change will affect them, it is clear that the loss of these snow and ice sheds will negatively affect the balance of global climate ecosystems and the vital resources that snow and ice sheds supply. In a recent article released by Climate Central addressing the bleak future of mountain glaciers, the researchers used a combination of regional temperature projections and topographic maps of specific areas considering the physics of ice flow to find that Canadian glaciers will lose at least 70% of their volume by 2100. What does this mean for the surrounding areas? Recession of these Canadian glaciers, primarily in British Columbia, will result in a lessened annual flow of the Columbia River, which provides enough power to the Pacific Northwest for 3 million homes to have electricity, just to name a single anthropocentric consequence. The reduction of this natural power source could be monumental for the surrounding areas. In the ring of the Arctic Circle, one can observe surging glaciers, meaning they are flowing at least 10 and up to 100 times faster than normal glaciers. While this is a natural phenomena for about 1% of the world's glaciers, scientists are now looking at surging glaciers to better understand how the majority of glaciers will act with rapid melting and what effect this will have on the rise of sea level. Researcher Andreas Kabb at the University of Oslo notes that understanding surging glaciers is vital to modeling sea level rise, which will be a direct effect of human-triggered climate change and will lead to a much faster sea level rise than anticipated. On the matter of how climate change is affecting the future of Antarctic ice sheets, environmental consequences continue to escalate. While of course wildlife and sea level are being heavily affected by the recession of these ice sheets, there are global issues in play. The two distinct regions of Antarctica, the east and the west, are joined together by encompassing ice sheets that act as a heat sink, significantly impacting global climate. In addition, the sea ice coverage surrounding the continent plays a vital role in the exchange of heat, moisture, and gases between the ocean and the atmosphere. Disruptions to this system due to the diminishing of sea ice would further affect an already changing global climate. In a recent study based on the IPCC report, Dr. Stephen Rintoul, a physical oceanographer and climate scientist, along with his colleagues, give a glimpse into the future of Antarctica in the event that we continue on our current path of fossil fuel usage and greenhouse gas emissions. The study predicts global air temperature will rise as much as 2.9 degrees Celsius, while Arctic temperatures as much as 3 degrees Celsius. The Arctic ice will continue to contribute to a 27-centimeter rise in sea level. Southern ocean temperature will rise by as much as 1.9 degrees Celsius. Summer sea ice extent will reduce by 43%. The ice shelf volume will reduce by 23%. Surface waters will become corrosive through ocean acidification, an increase of 10 times the amount of biological invasion, reduction in biodiversity, and increase of human presence and resource use. Understanding these future consequences in conjunction with those previously mentioned as a result of our current actions is crucial for motivating unified change on behalf of our environment. Without urgent change, the loss of these snow and ice sheds will promptly have negative effects on the balance of global climate, ecosystems, and the vital resources that snow and ice sheds supply.